greetings and good wishes. We welcome you all for this Rajarajan's educational channel. You are aware this particular channel is doing a service exclusively for education, like career guidance and counseling, and all the informations regarding education is concerned with. Now we are interested to help you for your academic curriculum also. To begin with, for 10th CBSE in physics, one question. So even if I said it is for 10th CBSE, this is there for the other curriculum also, like IGCSE, ICSE and State Board. And all the students can view this and you can make use of it. This is to help you to study further exactly what this academic curriculum needs. So to begin with, in physics, one question called Ohm's law. Ohm's law, study by Ohm. What is that? George Simon Ohm. So listen, the flow of a liquid depends on the pressure difference. You are aware? The flow of a liquid depends on the pressure difference. In the same way, the flow of charge, current, the flow of charge, this experiment is connected with electricity. So the flow of charge current through a conductor depends on the potential difference across its ends. How the liquid flow depends upon the flow of the liquid depends upon the pressure difference. In the same way, the flow of charge, that is current, through a conductor depends on the potential difference across its ends. Okay, this is what studied by Ohm, George Simon Ohm. Let us see what is Ohm's law. The statement of Ohm's law. If physical conditions like temperature, etc. of a conductor are kept unchanged, the strength of the current flowing through it is directly proportional to the potential difference across its ends. Try to understand. The physical conditions like temperature of the conductor through which current passes, we kept that as constant. The strength of the current flowing through the conductor is directly proportional to the potential difference, meaning the current is directly proportional to the potential difference, meaning let us take V as the potential difference across the ends of the conductor. I is the strength of the current flowing through the conductor. I is proportional to V. I increases, potential difference increases. I decreases, potential difference decreases. In other words, V is proportional to I. So, to remove this proportionality, we can introduce a constant Ri. V is equal to R into I. This is Ohm's law. This R is a constant of proportionality. This constant of proportionality depends upon size, nature of the material and the temperature of the conductor. This R is called electric resistance or resistance. R stands for resistant. That is the resistance I have shown here. It's a wire. Resistance. So for when just any object to move, the movement is opposed by friction. The friction is necessary. More friction should not be there. If there is no friction, we cannot stop an object. So normally we used to call friction as the necessary evil. We need friction for any movement. The same way, for the flow of current, resistance is needed. Resistance is nothing but the objection for the flow of current. Resistance is a property of a conductor to resist the flow of charges. To resist means what? To oppose. Here I have shown resistance. If you take V, potential across x-axis, and I, current along y-axis, if you draw a curve, that is you just draw a graph, it's a straight line. The same way, I and V. I is taken along x-axis, V is taken along y-axis, then again we get a straight line. The graph between V and I is a straight line passing through the origin. Why? V is equal to Ri, the equation of a straight line through the origin. So we get an equation that is a straight line through the origin. So V stands for V is equal to R into I. Now let us see the experiment. Now see this circuit diagram. A battery, a source for current. Battery, The group of cells makes a battery. There is one cell, few cells. Here I have shown a battery. The positive of the battery is connected to a resistance wire, Na. Then B is connected to an ammeter to measure the current. Ammeter is a device to measure the current. Right? Ammeter should always be connected in series with any circuit. Then connected to a key. Then subsequently to a rheostat. A rheostat to change resistance. A rheostat is a device to change resistance in any circuit. The experimental wire are across it, that is parallel to that is connected a voltmeter. The voltmeter is meant to measure the potential difference of any circuit. So this is always should be connected parallel to the resistance. Here in the diagram, B, battery to send current in the circuit. RS stands for rheostat, a variable resistance to change the resistance in the circuit. This is to change and adjust the current in the circuit. Now, whatever I explained, let's see how we have to present in the examination. A resistance wire R is connected between A and B. Yes, it is there in the diagram. An ammeter A to measure current in the circuit is connected in series. Yes, in the diagram it is there with the resistance R. The current passing through A, that is ammeter, is the same as that passing through R. The positive terminal of A is connected to positive terminal of the battery and its negative terminal is connected to the negative terminal of the battery. A voltmeter V is connected in parallel across R to measure the potential difference between the points A and B of the resistance wire. Again, the positive terminal of V goes to positive terminal of the battery and the negative terminal goes to negative terminal of the battery. Now, a plug key is closed or open as desired. I have shown in the diagram. When the key K is closed, a current starts flowing in the circuit. The current is changed by adjusting the rheostat and the readings of V and A are taken. V in voltmeter, A in ammeter. These readings gives us the value of potential difference across R and the current flowing through it. See the tabular column? I have just 5 experiments. I, current in amperes, V, volts. By changing the resistance, you can note the current. Yes, and R, V by I. So, you note I for various values, the corresponding potential difference V in volts. If you divide V by I, all these values is a constant. So, V by I is practically a constant. This indicates V is proportional to I. Thus, we have verified Ohm's law. Let's have a graphical study for the same thing. Take all the readings, whatever you have recorded in the tabular column, along the x-axis V, along the y-axis I. Or in other words, along the x-axis I, along the y-axis V. And just we have the readings in the tabular column. Mark all these in the graph, you can get a straight line. When we plot a graph between different values of V and the corresponding values of phi, we get a straight line passing through the origin O. This verifies Ohm's law. Graphical study. This is due to the reason that a straight line graph passing through the origin between two variable quantities. This shows the proportionality between V and I. Conclusion, V is proportional to I. Here, resistance R is V by I. That means resistance is always potential difference by current. That is 1 by I by V. That means what? I by V, slope of IV graph. 1 by slope of IV graph. The resistance of a conductor is the ratio of the potential difference across its ends to the strength of the current flowing through it. What is the unit of resistance? Ohm, the name of the scientist. To give respect to him, we call Ohm as a resistance, the unit of resistance. The resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when a potential difference of 1 volt is applied across its ends. How do you define 1 ohm? 1 ohm if a current of 1 ampere, the resistance of a conductor is said to be 1 ohm If a current of 1 ampere flows through it, when a potential difference of 1 volt is applied across its ends, R is equal to V by I. So 1 ohm is 1 volt by 1 ampere. So here the resistor is an object, it's a device of some conducting material having resistance of a desired value. Resistance is the electrical property due to which it opposes electrical current. This is the complete explanation of Ohm's law. Students, here we have given a complete theory of the verification of Ohm's law. You can just go through it, you can practice for it, and you may be interested to know the experiment. So in the subsequent episodes, we will do this particular experiment in this video. So probably in the subsequent sessions, we can organize a practical to verify the Ohm's law, and we will show all these devices, whatever explained here in the video. Thank you very much for watching.